This is part 1, an overview of quasi-experimental designs. So quasi-experimental designs look like experiments, they act like experiments, but they're not the real thing. So remember, an experiment is a type of study designed to clearly establish a causal relationship between the independent and dependent variables. And remember, in a true experiment, there have to be two components, one a manipulation or a treatment. The researcher has to do something to the participants, give them a medicine or apply an intervention or expose them to a stimulus, but there has to be something that the researcher is doing. And then random assignment means that the people who are getting exposed to different levels or conditions within the intervention have to be randomly assigned, meaning that each participant has an equal chance of being in one or the other condition. And we gave an example of nursing home residents who were randomly assigned to either participate in a Tai Chi class or participate in a walking group. And then they were going to take some measure of well-being. A quasi-experiment means that it resembles an experiment, but it's not. So it may lack random assignment, meaning that the people in either of the conditions are not assigned by random, but are part of that group through some other innate condition. And secondly, it may lack a manipulation or treatment. Now, there are different ways of categorizing what is a quasi-experiment and what is a non-experiment, and we'll follow the way your book is organizing it, but don't be surprised if you see things defined a little differently in different situations. So a true experiment on the right, we have the one group of individuals who are randomly assigned to either the treatment or the control. So there's a manipulation present. The researcher is doing something to people in one condition that they're not doing to the other, and the people are randomly assigned to get put in those groups. In the first type of quasi-experiment, we measure an outcome between groups that were not randomly assigned. So people already belong to these groups, so they've sort of self-assigned, maybe by joining a club in the one case and not in the other, or by by being part of one class and not another, or by engaging in the behavior and not in another. In some way, these two groups are different. And then we give them an intervention and measure some outcome. But the groups are different in the first place. They weren't randomly assigned. Or we could even have a type of quasi-experiment that some would articulate as a non-experiment, in which we just measure outcome for one group of participants before and after an intervention, or sometimes even just after an intervention. And in this case, a manipulation is present. There's no comparison group, though, so there's no random assignment. So these are what we're going to be looking at today. So just a couple of examples. First of all, let's say that we had this research question. Do women who smoke during pregnancy have lower birth weight babies than women who don't smoke during pregnancy? And now think about how we could test this. If we were going to do an experiment, we would have an independent variable, cigarette use, and we would have two conditions, smoking versus not smoking during pregnancy. And then we would measure our dependent variable, infant birth weight. But in order to be a true experiment, we would need to randomly assign pregnant women to either smoke or not smoke while they're pregnant. Do you think we could do this? Would this be realistic? Is this possible? And the answer is absolutely not. It would be a huge ethical violation. Women would not agree to participate. A woman who doesn't smoke would not agree to suddenly start smoking in order to be part of an experiment. And so there could not be random assignment to test this hypothesis or answer this question, so we need to use a quasi-experiment, something that is sort of like an experiment but isn't. Another example, stress response. The research question is, do males and females, I'm talking about adult males and females, differ in their stress levels in response to an infant crying? And so the independent variable is the adult sex, male versus female. And the dependent variable is how much they get stressed when an infant cries. So the researcher intends to expose males and females both to the sound of a baby crying and measure their cortisol levels. So here's the question. Can we randomly assign people to be males and females? And the answer is no, of course not. People are already males and females. We can't assign them. Random assignment is not realistic. We need to use a quasi experiment. Last example, donating. Let's imagine this research question. Do people who survived a natural disaster, such as a wildfire, have higher levels of donations to aid agencies than people who've never experienced a natural disaster? And so the independent variable is a natural disaster, either survived or never experienced it. So people are going to belong to one of those two groups. And the dependent variable is donations to aid agencies. Can we randomly assign people to experience a natural disaster so that we can do a true experiment? And again, the answer is of course not. Natural disasters occur out of our control, and we can't assign people to experience one. Once again, random assignment is not realistic, so we need to use a quasi-experiment. So you may recall from earlier reading that we have two types of broad categories of designs: between subjects designs and within subjects designs. And between subjects designs are when different people are exposed to each condition and their scores are compared. An example is here. These individuals have been chosen from the population and they're divided into two groups. We don't know whether random assignment has occurred because it's not stated, so this could be an experimental design if random assignment occurs, or a quasi-experimental design if there was no random assignment. And then they're exposed to either a treatment and control condition or two different treatments before the outcome variable is measured. In the second bullet point, a within subjects design is when one group of people is assigned both to treatment and control conditions, and their scores are compared in both conditions. So it's within subjects because you're comparing this person's score in treatment A with the same person's score in treatment B, and we're doing that for all of these individuals. So in a simple within subjects design, this group of people might be exposed to treatment A, a measure would be taken. They would be then exposed to treatment B, another measure would be taken, and these scores would be compared. And they'd be compared within each individual because each person's score is dependent on being that same person. So we will talk then about three types of designs that will fit either into between subjects or within subjects designs, or in some cases both. So the first is the causal comparative design, the design that was articulated in your last chapter, but not in so many words. But this is a simple design where we compare an outcome variable between conditions that are static in individuals, like their age or their gender, something like that. And we call it causal comparative because we're trying to assume that the fact of the static variable, like their age or their gender group, is what causes the impact on a dependent variable. So we're comparing the dependent variable across these static conditions. And this kind of design would be a between subjects design because different participants are compared across conditions. A person cannot be both in the male and the female group typically, or in the 20-year-old cohort and the 40-year-old cohort. Each individual belongs to only one group, so it is a between subjects design. A one-group design is the next type of, we'll look at several studies that fall into the category of one-group design. And what that involves is measuring an outcome variable in a single group of participants before and or after an intervention. And this is a within subjects design because this one group of individuals produces scores for both the control and the treatment conditions. And then non-equivalent group designs is measuring an outcome variable in groups of individuals that have not been randomly assigned. So then the groups can't be considered equivalent because there's been no random assignment. And typically this would be a between subjects design because the two groups of individuals can provide scores, and each participant can only be in one of the two groups. They can be both between and within subjects' designs if the scores are also compared within each person, such as with a pre-test post-test design that also uses a control group that also takes the pre-test post-test. So we'll look at each of these types of designs individually.